All right, so we are doing a 9F, which is differentiating rational powers, meaning when we have pronumerals to the power of a fraction. So we're going to use the index laws that you know already, and we're going to use the chain rule. So we're just going to practice here what we already know. Hopefully you know that x to the power of a half is the same as the square root of x. Okay, as you should also know, x to the power of a third is the cube root of x, and x to the power of, say, a tenth is the 10th root of x. That should be something very easy. So now we just need to remember what the 4 means. So we know the 3 on the bottom means the cubed root. And what is it of? It is of x to the power of 4. So this one, we're still just doing the index laws. We're not differentiating. So we are going to say the 3 comes out the front, and inside, underneath, we have this part of the function, and it is to the power of 2. All right, having a look at this one. What does this mean? So the 2 on the bottom. So because this is a negative, we're going to start by going like this. Okay, just so we're not messing around with negatives and square root signs. So this will become 1 over, oh, I've missed something there. Oh, I haven't put this on, 3 to the power of 2. 1 divided by, so the 2 means square root, so we just want to do square root. And underneath we have 3x minus 2x squared to the power of 3. All right, so now that we've recalled those, let's have a look how we can use them to find derivatives. So we have y equals, so we're going to have dy dx equals, and from what we know, we multiply the constant term, the number in front of the pronumeral with what's here. I'm going to write it out long ways to begin with. So it'll be 4 times 5 to the power of 3 x, and we're going to go 5 over 3 minus 1, so minus 3 over 3. So our final answer is going to be 20 over 3, and then x to the power of 2 over 3. All right, now you don't need to put that in what we've just done at the moment, although you might need to if there's a multiple choice question, but that's a good answer, that's fine. It's more when we go backwards that we need the stuff that we just did up the top. All right, you could leap ahead from me now while I don't talk and do this one, which is pretty much exactly the same. All right, so you can see here, this is the, just these numbers have been swapped. So we've got a negative here. So we do want to finish this off nicely. This whole thing's going to go on the bottom. So we're going to have a 12 on the top. And on the bottom, we're going to have 5 times. And I'm going to write this out with the cube to show you, with the square root sign, the root sign, I should say, to show you how you might also see it. So underneath we'll have 5th root, and under the root sign we'll have x squared. All right, let's keep going. So here is why we needed to practice what with this. So this should be f of x equals. I'm going to write out what that actually means, and that this is why we needed to do the first step. So 3x squared plus 4 is the root sign with nothing out the front, so it means it is a half. Now this one here is a little bit different because it is going to now use the chain rule that we just learnt. All right, because there's 2 steps to it. So we're going to do differentiating the whole part, so half bracket 3x squared plus 4. And then this is going to be a half minus 1, so that'll be to the power of negative a half. Then we need to multiply by the differentiation of what's inside the bracket. As I said, our chain rule. 3 times 2, so this becomes 6x. Then a half times 2 is 3. Now this is a minus, so this whole thing is going to end up on the bottom. So on the top, a half times 6 is 3, so on the top we're going to have 3x divided by square root sign 3x squared plus 4. So now we're doing differentiating with fractions, including the chain rule, okay? All right, what does this mean? Let's write it out. So still y equals, this is the same as 2 bracket 2x minus 3x squared. The 3 means it's over 3, and it's not to the power of anything there. So that is to the power of 1/3. So this is what we now have to differentiate. So we have dy dx is equal to something in the bracket, so we're going to use the chain rule. So let's do the whole first. So we're going to go 2 times 1/3 bracket 2x minus 3x squared. 1/3 minus 1 is minus 2/3, and we multiply that by the differentiation inside the bracket. Differentiating inside the bracket, we get 2 minus 6x. All right, so let's bring this together. I'm going to deal with everything that's on the top. So this is going to be on the bottom, and so is this. So you can leave the 3 there. Don't play with this. So on the top, we've got a 2 here, and we've got this part, so 2 minus 6x. On the bottom, we have this 3, and we have this here. And I'm going to put it into the different notation, so you get used to it. The cube is out the front, and we have 2x minus 3x squared to the power of 2. All right. Now we're going to do that as the same as we did with the last exercise, where you differentiate, but you have a value to plug in so that you can get the rate of change of the tangent to the curve. All right, so let's differentiate this. So no chain rule for this one. We're just going to go 4 times 3/5 x, and we're going to go 3/5 minus 5/5. Most of you won't be writing this line, and that's fine. You don't need to. Just trying to make it nice and obvious for you to begin with. So 12 over 5 x to the negative 2/5. What have we got left? We have just a 12 on the top. This whole thing is going to go on the bottom. So 12 divided by 5. What does this mean? 5 out the front. The minus means we're on the bottom, so that's taken care of. And this is x squared. And the question is wanting to find the rate of change where x equals 1. So we're going to go x is equal to 1. We get 12 divided by 5 times the 5th root of 1 squared, which is 12 divided by, this will just be 1, so it's going to be 12 divided by 5. So at x equals 1, the rate of change is going to be 12 over 5. So you guessed it, here's another one, but when we have to use the chain rule first. So we're going to go dy dx, equals, I'll change that into what it is. So this is to the half. Oops, so I don't want dy dx there, I want y. Now we're going to differentiate dy dx is equal to, all right, so we bring out the half to the front, keep what's in the bracket for now. We're going to go half minus 1 is negative a half. Chain rule says we have to multiply by what's inside the bracket, so that's going to be 6x. All right. Now, this time, because the 2 and the 6 can cancel out, we're going to do that. So we're going to do a half times 6, and we get 3. This part is all on the bottom. This is going to be on the top. So a half times 6x is going to be 3x. And we're going to change that to square root 3x squared plus 4. Now the rest of the question says when x is -2. So we want to put in when x is -2. So 3x over square root 3 times minus 4, which equals 3x divided by 12 plus 4 square root 16. Oh, I didn't put x. Yeah, I didn't put it in here as well. That was silly. You've all done it, I'm sure, saying Mrs. Thomas. You didn't make x up the top equal -2, so thank you. Oh. So we have minus 6 divided by 4, which is the same as minus 3 over 2. Excellent. All right, let's flip over the page. We've got a couple of pages for this exercise. Now, much to your disappointment, we have to go back to first principles, the one that takes a little bit of time. Although, what have I done? I can do this in about 3 steps, so don't freak out. All right, let's remember what first principles is. So let's just write this down first. F of x plus h minus f of x divided by h. All right, now that is what our first principles is. So now, instead of x, we're going to put x plus h. So this is the same as 3 square root x. We're going to work with that. So on the top, we've got 3. Instead of square root x, we've got square root x plus h minus just what it is, 3 root x. And then divided by h. All right, so now we are going to use, I can't remember what it's called, when we multiply both to get rid of the square root sign. Oh gosh, sorry about that, I can't remember. So we multiply root x plus h plus 3 root x. And if you do that to the top, this is all to get rid of the square root sign. Okay, so it's like expanding it out. And if you do that to the top, you've got to do it to the bottom. So I'm going to put that on the bottom as well. Now, if you wanted to, you could expand that all out and make sure that I'm telling you the truth and not sending you on a wild goose chase. All right, so from here, this part here, what does that become? Sorry. So first of all, I should have done that in that step actually. We are going to take out 3, because if we take out 3, you'll see you've got this. Oh gosh, that should not be a 3. Sorry everybody. Is it rationalising the denominator? That's what it is. Okay, divided by h multiplied by this. So I've just put in an extra step there. When you have to do these, come back to this example, copy it straight from here. They don't change much. I should have perhaps taken the 3 out and not bothered about that line in there, but that's okay. All right, so this part here is what makes us rationalise the denominator so that it becomes 3, just what you've got there, so x plus h minus x. So, as I said, if you want to test it, this times this gives us the whole function there without the square roots. Now, I'm not going to multiply that all out and prove it to you because that's been done in the past. But if you want to go and test me, then please go do so. All right, and on the bottom, we are going to have h, and then what we've had to put in here, x plus h plus root x. All right, what happens here? You can see, hopefully, x minus x, so they just go. So we have 3h over h. Write it all out again, bracket x plus h plus root x. All right, the h's are going to go. So what you've got left, I'm going to go back over here, is 3 over square root x plus h plus square root of x. All right, so that's what we have by first principles. Then, to get it, we're going to do the limit as h approaches 0, because that will give us our value, and plug that in. So we have 3 divided by, if h is 0, this becomes root x plus root x, and that is the same as 3 over 2 root x. Okay, and if you were to do this the way we've taught you, the quick way, which I'm not going to do now because I don't want this video to go for too long, then you're going to get that answer. All right, so if you ever get first principles, don't forget you can check within 2 seconds if you're correct or not. All right, what if we get a tricky question like this? Let's just do it slowly. So if y equals this, show this. So basically what they're saying is find dy dx, and hopefully once you've done some work for it, you're going to get what this is. Okay, so we're going to go straight for dy dx equals, and we're going to differentiate just the outside function. So this becomes 2, leave what's inside as it is, and 2 minus 1 is 1. So that's just going to stay there. Okay, but to that, we are going to have to multiply the differentiation of what's in here. So we need to differentiate, as you know, from the chain rule, what is in here. So if we differentiate x, we get 1 plus, oh my gosh, we have to differentiate that. And that has something inside as well. So we're going to do the chain rule inside the chain rule inside the chain rule. So just take care. So again, first of all, we do the outside. So we're going to have a half. And I'm going to put that into, yes, no I won't. I'll do that on the next line so I don't confuse people. All right, this becomes x squared plus 1 to the power of what have I done there? Why did I do a half? Chain rule is... Yep, okay, sorry. You've probably gone ahead of me now, which is great. I've confused myself. Sorry. All right. Chain rule of outside will just be 2x. Okay, so this is like a to the power of 2, so that's just 2x. But we have to multiply that by, and this was a plus because this is a plus, we have to multiply that by whatever the chain rule is with inside. So that's the same as x squared plus 1 to the power of a half. So we have to do multiplied by that differentiated. So that's going to become a half x squared plus 1, and a half minus 1 is minus a half. All right, I'm sorry for that. I hope you can, as I say, you've probably gone ahead and done it. But if let's just have a look. If we have to differentiate this, first of all we differentiate as if this was a whole function, so like x to the power of 2, squaring that, differentiating that, we get 2, multiply that by what's inside. Okay, so going on from this, we are going to see how we can play with that a little bit. All right, now x plus I've done that already. Okay. Next step, let's leave this as it is. Hopefully you've gone ahead because I'm being a bit slow today. All right, so let's leave the 1 plus 2x times a half. We can do that. So that's just going to become a half x squared plus 1 to the power of negative a half. Okay, over here, 2. Let's just leave this as it is. X squared plus 1. All right, now I'm doing a lot of lines here just for those who might get a little bit confused. All right, so now we're going to incorporate the 1 so that we can make this look a bit better. So 1 is the same, this is fraction, so 1 is the same as x squared plus 1 over x squared plus 1. And we're going to add that to x over x squared plus 1. Now they've got the same denominator, so we can just add the top. So this becomes, leaving that here again, 2x plus x squared plus 1. And now this becomes multiplied by, so on the top we have got x squared plus 1 plus x over the denominator of x squared plus 1. Goodness gracious me, let's see what happens now. So across the top here, we are going to get, now let me see, this here, you will see now, there's my highlighter, this is the same as this. So we can rewrite that top line as 2 bracket x plus root x squared plus 1 all squared, because there's 2 of them, we're multiplying them together, divided by, what's on our bottom, x squared plus 1. Now, what you want to remember though to finish this off, so I'm going to write remember that y actually equals, let's just go straight for how it's written up the top. So I'm going back to the question, x plus x squared plus 1 all squared. Therefore, our final answer, dy dx, is equal to, this is this. So it's the same as 2y over square root x squared plus 1. That's pretty hard. There's a lot of work in there. It's pretty hard. I made mistakes, so that wasn't helpful. Okay, there's your questions to 9F. Please come back and in and seek some help if you need it.